For today, we will go over the SAT practice test number 10, modules 2, questions 25 and questions 26. So starting off with question 25, it reads, which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? This question is one of those questions where you have to look at the answers given to formulate a response, because if you weren't provided these questions, then it's very difficult or it's near impossible to answer this prompt. So one thing I noticed is that we want the expression to have a factor of x plus 2b. If x plus 2b is a factor, then we can rewrite this as x equals to negative 2b. And we must make the expression equal to 0. So we can just try each question out, or each answer out. So we can start with number A, or letter A, sorry about that. We have 3x squared plus 7x plus 14b. Let's substitute negative 2b for all the x's, and we will get something like 3 minus 2b squared plus 7 times negative 2b plus 14b. We can multiply the 3 into the expression and multiply the 7. And 2 squared of negative 2 is 4. 4 times 3 is 12. So we have 12b squared. 7 times negative 2 is negative 14b plus 14b. I see that the negative b and positive 14b will cancel each other out. Hence we are left with 12b squared. Since we're told that b is a positive constant, there is no number that will set this to 0. So because b is a positive integer, we know that we can't make this right. So hence a is not a possibility. Let's move on to b. Again, same thing. I'm just going to substitute the negative 2b squared into the x, and we'll get some equation like 12b squared minus 56b plus 14b. We can combine the b terms, so we will get 12b squared minus 42b, and this will factor out into 6b times 2b minus 7. And for this to equal to 0, we would need 2b minus 7 equals to 0. Because if this term equals to 0, the entire thing will be 0. And we know b can't be 0 because it has to be a positive integer. Hence that we have to look at the inside term. So we would get something like 2b equals to 7, b equals to 7 over 2. And because we're told that b must be an integer, this also will not be a possible answer. What an integer is any number that's like a whole number, like a 1, 2, 3, so on. Because it's a fraction, it's not an integer. Okay. I need a bit more space, I'm going to delete this. I'll leave A here for a reference, but moving on to C, again, same thing. I'm going to put negative 2b into x, and we will get now moving on to C, we have 3x squared plus 42x plus 14b, and if we plug in negative 2b for x again, we would get 12b squared minus 84b minus 84b plus 14b. Again, combining the b terms, we would get 12b squared minus 70b equals to factor out of 2b, we would get 6b minus 35. Again, b cannot be 0 because it has to be an integer. So we plug in, so we solve this to equal to 0. 6b minus 35 equals to 0. So we would get b equals to 35 over 6. Again, it's a fraction, it's not a positive integer, so c is also wrong. By process of elimination, we would see that d is the correct answer, but just to go over d, we would get, again, plugging in negative 2b, we would get 12b squared minus 84b. We'll factor out at 12b equals times b minus 7. Again, looking at this term, set it to 0. We find that b equals to 7. 7 is a positive integer constant, hence we found our answer for D. I think a lot of these questions which say has a factor of x plus 2b. The trick is that oftentimes we need to solve for x plus 2b and just simply rewriting it as x equals to negative 2b, or we can also solve for b. In this case, x would have been a lot easier, and so we plug this term into the given algebraic equation, and then you want to isolate and solve one variable. So what you're really doing is that you're given some equation with an unknown x variable and an unknown b variable. You have two unknowns. You want to make it simpler by using some equation to substitute this x term with a b, hence you're having a consistent b term in your equation. And I think this is what this question really highlights and goes over. If you have any questions, let me know in the comments. I'll try my best to get to it. But we're moving on to question 26 now. This question is like a data set question, like a graphing question, and it's kind of testing your ability to interpret data given some graph. So we're given data set A and data set B. We see on the y-axis we have the frequency, and the x we have integer. Another way to think about it is that normally they call the x-axis as, they normally call the x as the independence variable, and y as dependence. Oftentimes people get confused as to what makes the x independent, what makes the y dependent. The reason why we set the x term as dependent, or we set the x term as independent, is because oftentimes we're calculating the frequency based on we're calculating the y based on the x. So, for example, it's common to set the x term as some value, and then we're going to use that value to interpolate what the y value is. That's like a really brief explanation. I can go a bit deeper into it later in the future, but that's all you really need to know. So for this question, it reads, two data sets of 23 integers each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. So what that really means is that some box plot is set from like 10 to 20. If I were to like zoom in on this right here, all it's saying is that the frequency of integers greater than or equal to 10, but less than 20. So for this example, the frequency here is 3. So that means there are 3 numbers that are, there are 3 numbers that are greater than or equal to 10, but less than 20. not equal to 20, but only less than. So you would have this little angle without the equal sign. And that's pretty much all this box is showing. Okay, moving on. The second interval represents a frequency of integers greater than or equal to 20, but less than 30, and so on. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? So the first thing we can do, we can just read the frequencies. What that means is that you're just adding what the y value are. So at the first box, we see the frequency value is 3. For the first box, we get 3. For the second box, we get 4. For the third box, we get 7. For the last box, we get 9. So that will equal to 16, 20, 23. That's what the frequency is. Now notice that every group in A is exactly 10 greater than the corresponding group B. What I'm trying to say is that the heights of the first box correlates to this box. The height of the second box correlates to the second box. So the question asks for the smallest possible difference, so we need to make A's values as small as possible and B's value as large as possible. I'll say that one more time. Because the question is asking what is the smallest possible difference between the mean of dataset A and the mean of dataset B, we can minimize that by making A's value as small as possible and B's value as large as possible. That makes sense because if we're comparing box 1, we can label these boxes as 1, 1, 2, 2, 3, 3, 4, 4. Let's only focus at box 1 for dataset A and dataset B. Looking at box 1, it is greater than or equal to 20, but less than 30. Set B, box number 1, it is less than or equal, or it is greater than or equal to 10 and less than 20. So just looking at that box, what if we make A as small as possible? If we make A as small as possible, it could lead to the number 20. If we set B to the largest possible number, it would be, because it cannot be 20, the next possible integer is 19. And notice how there's a difference of 1. What if we repeat that process for boxes 2, 3, and 4? You would get the same thing, because the difference between set for the box 2, for example, you would get 30 and 40. For B, you would be greater than or equal to 20, less than 30. Again, minimize A, so we would get 30. Maximize B, so we would get 29. Again, difference is 1. Again, this is just like it's not a concrete proof, it's kind of just eyeballing things. We can do this through a different method too. So one way we can do this is to make A as small as possible. So we would predict that, we would just assume that every single integer in the box is the lowest possible value. So in box 1, the lowest possible value is 20, and there's 3 of them because the frequency is 3. We can do 3 times 20 plus 4 times 30, so on and so forth, plus 7 times 40 plus 9 times 50. And that would get 60 plus 120 plus 280 plus 450 goes to 910. Now let's make B as large as possible. Because the intervals contain integers, the largest values are 1 less than the upper endpoint. So just looking back to this set B, you see the largest possible value in the range of box 1 is 19 because it has to be less than 20. So let's do that. Three times 19, again 4 times 29, 7, 39 plus 9 times 49, and we would get 57 plus 116 plus 273 plus 441 equals to 887. Therefore, the smallest possible difference between the sums is 910 minus 887 equals to 23. So this value is the smallest, or this value is the smallest possible difference between the sums. So if you add up everything and assume that set A is the smallest number and set B is the largest possible number in the range, then this is the difference of the sums, or this is the possible difference between the sums. The smallest possible difference between the sums. And again, since both datasets contain 23 numbers, the difference between the means would be the difference between the means is 23 over 23. Again, it's just like the smallest possible difference between the sums over the number of data sets, the number of points in the data sets, because it contains 23 numbers if you remember adding up their frequencies. So 23 over 23 equals to 1. And this question is a lot. It is pretty difficult to understand intuitively and to get a concrete answer. So again, if you have any questions, feel free to ask in the description or in the comments below. Thank you.